Bismillahirrahmanirrahim. Welcome to revision lecture 1 of computer programming for civil engineers. In this lecture, we are going to get introduced with Python language and its environment. We'll install Python. We'll see how other libraries are to be installed and what are other libraries. And we'll learn how to work in Python environment with the help of some examples. So let's start with it. First of all these details are available on the website of this course, and here I have opened up this website on the left side, the first presentation and the download links for all tools that you need for this course. So I will advise you to install Anaconda, because once you download and install Anaconda, it installs Spyder, Python, and PyPy for you as well. Now, what are these? We will see them now. So if you click on the download Anaconda link, it will open up this website for you, from where you can download the latest Anaconda extension for you. I'll advise you to install 32-bit because it has lesser errors compared to 64-bit version. It automatically installs Jupyter for you, all other SciPy, NumPy, Spyder, and other libraries as well. With the passage of time, you will mainly be introduced with SciPy, NumPy, Matplotlib, and Pandas. Let's go back to our website and see what are other things. After installing Anaconda, as I told you, it will install Python as well as Spyder for you. So let's see these other tools as well if you want to install them separately. To install Python separately, once you will click on this download Python link, it will open the website for Python, where you can download the latest version for your computer. If you click on the Spyder link, it will open up this website for you, from where you can download Spyder. Spyder is an environment which is most like the MATLAB. So all of you are already familiar with MATLAB. It will be very easy for you to work with Spyder, and I will advise you, and in coming lectures we will also be mostly using Spyder. Let's go back to our website, and if you click on download projects from PyPy, it will open up this link for you. And currently there are around 3 million project files that are running, and more than 2 lakh projects running on it. People and programmers like us keep writing these small packages for us that help us in doing complex tasks very easily using Python. So I'll get you familiarized few of these packages in this lecture as well. So if you install Anaconda, it will not only install this Python for you, but it will also install Spyder for you, and also install all the packages that you need for this course. So after downloading Anaconda, you will see a file like this be downloaded, executable file. You double click on it and install Anaconda for you. If you have downloaded only Python, you will see a file like this will be downloaded, and you can install Python only from this executable installation file. So from now on, we'll be talking about Anaconda and our Spyder. So after installation of Anaconda, let's see what we get. So if you click on your Windows icon, you will see Anaconda option in the menu. If you drop it down, you will see you can run Anaconda Navigator from here, but you can also run Python directly from the Anaconda prompt. To write bigger programs, you can use a Spyder, which is much easier and very handy environment compared to typical Python prompt environment. And you can also write programs using Jupyter Notebook. It is a very useful tool for documenting your programs. So if you want just to write a program and to run it for your use, you can use Spyder. if you want to write a program and you want to document every line of it and then what it do as well, and you can do that work in Jupyter. So I'll get you introduced with all the three: the typical Python environment, the Jupyter and Spyder environment, but in coming lectures, we'll mostly be using Spyder. So all these three do the same thing, and I'll show it to you in a while. So from our lecture, the first thing was to install Python. So we have installed Anaconda, which has not only installed Python for us, but also installed better environments for working in Python, which are Spyder and Jupyter. So let's see first of all the command prompt form of Python. The command prompt environment of Python is the most basic environment, and you can use it quickly to test your program or run your program. So let's get familiarized with the command prompt environment first. But as I said, mostly we'll be using Spyder environment. So from the Windows button, we'll click on Anaconda 3, and then from here we'll click on Anaconda prompt. Now this is the DOS prompt environment. It is just like normal DOS. Here if you write Python, it will start Python for you if you press enter to it. Now Python has these three arrowed prompt. So whenever you write anything here for calculation purpose or for writing a program or for testing your program, it interprets it on spot. For example, if I write 2 plus 3 and press enter, it will interpret it on spot and it will give you the result. But if you write 2 plus 3 in any other program like Microsoft Word or Notepad, for example, I open Notepad and I write 2 plus 3 and press enter, nothing happens. So what Python has done is it has interpreted it quickly, and whatever was the result, it has shown it to you on the screen as well. So what I mean to say is that if you are using the command prompt environment of Python, that environment is actually an interpreter, which means whenever you write anything, it understands it on spot and show you the result at the end quickly, as we'll learn about this prompt more in future. If you want to close Python, you can type quit within and the parenthesis. So I'll type here quit and with parenthesis and press enter. It will quit Python and you are back in your DOS environment. Python is a programming language where you can write your small programs and do mainly some calculation works. It cannot do very sophisticated work. For that, you will be installing some other projects or programs with it. For example, NumPy, SciPy, and Matplotlib. So these are few things that Python cannot do. It cannot work on matrices. It cannot do integration and differentiation, and it cannot draw graphs for you. In order to bring the capability of doing matrix calculation, doing integration and differentiation or calculus, and drawing graphs and plots, you have to install these three libraries, which are called NumPy, SciPy, and Matplotlib, respectively. In order to do so, you have to write this statement in your command prompt and you have to press enter. If NumPy is already installed, it will tell you, otherwise it will take some time and install NumPy for you. So for now, because NumPy is already installed, because as I said, and after installing Anaconda, it will install all useful stuff for us automatically. So it is already installed. But there is something, if it is not available in Anaconda and you have discovered this library on the library pypi.org website, you can install it in the same way by typing such type of statement and writing or replacing the name of the library here. as we can see for NumPy, SciPy, and Matplotlib in these three examples. So now, just to get familiarity with Python, we are going to do a small project of matrices. So we are going to create a 3 by 3 matrix and we'll name it as A. We'll find a transpose of it, and then we will multiply A with the transpose of A, and we would like it to be stored in the computer memory by the name of B, so that whenever we call B, we get the result of A cross A transpose. Or if we write A, or if we ask Python what is stored in AT, it will tell us the values or the whole matrices stored in variable A and variable AT. So in order to do that in this environment of prompt, we have to enter into Python by typing python and press enter. Next, because we know we want to work with matrices, but Python cannot work on matrices, we have to import the installed NumPy library in Python. And if we want it to be simply called NP, for example, we will import it by this name, but you can import it by any other name as well. So for example, here I will write import NumPy library as my name, for example. Now whenever I will write ADIL or Adil, it will represent a library which has capability to solve matrices. So if I press enter to it and there is no error that appears on the screen, then it means everything went fine. But if I do some mistake in writing, for example, writing double T with import and press enter, we will see an error appearing on the screen which tells what is the mistake, and it says that this is an invalid way of writing it. So now, as we have imported NumPy, now NumPy, the matrices tools are available by the name of ADIL. So let's make our first matrix. Now first matrix has first row called 1, 2, 3, the second row called 4, 5, 6, and the last row of 7, 8, 9. So it is a 3 by 3 matrix. In order to create that in Python, you want to store it in the variable called A. So let me first of all create it without storing it in computer's memory. So if you want to create it, you will call NumPy, which is now called Adil. So let me write ADIL dot array. Now array is a specific keyword in NumPy for defining matrices. So whenever you want to create any matrix, you have to use the method of array. So whenever you create anything using any method, you have to mostly close it in parentheses. So within the parentheses, let me now create the first row of this matrix. Now in NumPy Python, we create a row in box brackets. So within box bracket, if I write 1, 2, 3, now first row is created. In order to create a second row, I have to close that second row within box bracket as well, which is 4, 5, 6, which are the three elements in the second row. But both of these rows should be also separated by a comma. And the last row after a comma in box bracket will be, for example, 7, 8, 9. Now to tell NumPy that these are three rows of a same single matrix, all of these should also be closed in a box bracket. So overall throughout, we'll close it in box bracket. So now in a big box bracket, we have three box brackets. Within them we have comma separated every individual element of every row. and every row is also separated by comma as well. So now press enter. It will show me what it has created, but I have no way to access it again because it is not stored anywhere. So now I'll write that all again. I brought the command again by using up arrow key on my keyboard. So if you keep pressing up key, it will keep showing you old commands that you have used in Python. So now let me, in the start, let me store all the results in a variable called A. Now in computer's memory called RAM, all this matrix will be created again, but this time it will be stored inside a variable A until you close Python. So once the Python is closed, all this data will be lost. It will not be stored in your hard disk. So now if I press enter, it has not displayed anything on the screen because it is actually stored in a computer RAM in variable A. So let's check it out. We can check it by printing it on the screen, and within the parentheses I'm going to tell the Python print command, Python print method to print something. So I want to print A now, so let me press enter to it, and now it will show what is stored in a computer memory which is named as A. So next we want to store the transpose of A in a variable called AT. So I'll write AT equals to ADIL because this NumPy is available to us in Python by the name of ADIL, and it would be an easy name for us. So dot transpose. Now again, in NumPy, if you want to create a matrix, you write array, and if you want to make a transpose of that matrix, you write transpose simply. Within the parentheses, if you tell what you want to transpose, which is A, and press enter to it, it will create a transpose of this matrix and store it in AT. So let me show this matrix again, this time not by writing print A, but just writing A only, because Python command prompt environment is an interpreter, or a console environment is an interpreter. So whatever I write and press enter, it is understood by Python at once, and its response is shown at once as well. So it tells this is what is stored in A, and if I write AT enter, it shows that as well. So we'll see where print A is useful, because in some environments, as in some places, we don't have interpreter available. So there we have to force showing something on the screen by writing print A. But luckily Python interpreter can show the variables without print. So now we can see both matrices are transpose of each other. Another good option in NumPy for transposing is that if you have a matrix, for example A, and if for this matrix you write dot T at the end and press enter, it will be the transpose of A already. So if we don't want to waste the computer memory to store a separate matrix A in variable A and another separate matrix which is the transpose of A in a place which is named as AT in the computer's memory, that is a double usage of space. So if you want to save space, just keep A stored in variable A, and whenever you need a transpose, just simply write A dot T. It will give you the transpose without storing it in any computer memory. Let's now finally multiply A with AT and store the results in B. So you will write ADIL dot matmul, because this is the method or command that is used in Python for matrix multiplication. And within the parenthesis, we will write multiply A with A T. You want to store the results in B, but before that, let's see what is the result. So let me press enter to it, and this is the result of the two matrices multiplied together. Now let's repeat this again, but this time instead of A T, let's write A dot T. So this time, if we have not stored the transpose in another variable AT using this command, if we haven't wasted this computer memory space by creating it, we only have saved, we would have saved a single matrix in A. We can use the same for with the transpose as well and see we get the same result or not. So press enter for it as well. So yes, we get the same result for both. So we actually never needed to store the transpose of A in a variable AT. Now let's store this result of A dot A multiplied with A transpose in a variable B. So behind it, I write B is equal to this. And now I press enter. This time it is not showing the result on the screen because it is actually stored in computer memory. So now whenever I write B and enter, I'll now see the results stored in the memory. Whenever I want to see what's stored in A and what's stored in AT, I can always see them by simply typing them or writing them in print A or maybe print B. Press enter so you can see the results of the variable like this. This was about the Python interpreter or Python in console environment. This is you can use it just like a calculator as well for not only doing simple calculations by adding numbers or multiplying them, for example 6 multiplied by 4. So, but you can actually do much complicated matrix calculations and integration and differentiation and showing their graphs and much more as well. So let's exit from it by writing quit parentheses at the end. Press enter. So now we are out of Python and we are back to our DOS environment or console environment. Now let's do the same thing again in much better work environments that are available for us from Anaconda. So let me close Anaconda prompt and let me run Anaconda Spyder. So after closing it, from Windows button, I click on Anaconda 3 and then from here I run Spyder. Now Spyder is, as I mentioned earlier, it is an environment which is very close to the MATLAB environment. So if you're not familiar with MATLAB, then knowing Spyder environment will also get you familiarized with MATLAB. Now, once the Spyder is running on the screen, you will see this time you can write your programs here and store them in a location where you so currently I'm this file. Beside this portion called console is actually the same console as Anaconda prompt. Instead of A1, you can consider it as the 3-arrow prompt of Python. For example, if you were to put this 3 here and press enter, it started as for example, board about notice how colorful it is. That is the step. This is something which opening or closing. This is the closing bracket in the city of New York. It's a very handy and easy to use. So we have two rows here. Six, seven, all of which should also be used. Bigger bracket should exist. Press enter to so this is total A. Also so the same environment as we had here in Python and Anaconda background also is available here, but it is more colorful and easy to use. And it helps you in finding your mistakes and correct them easily as well. So upkeep will start working with the same tools. All this consisting as a program here, but that is common. So now let me use you with the other Jupyter environment. Do the same task. Here, if you click on Variable Explorer, we also have a list of variables and what are they and what is stored in the computer will be shown. For example, here we have after if I create another transpose equals to AIT, so the transpose of A press enter, you can see automatically it will show that variable transpose of this matrix and it is a 3 by 3 matrix whose portion is to be shown here because sometimes a small group can store huge data and showing all of the capabilities. Complex split where it is a 3 by 3 matrix stores this. So in the console environment we were not able to see what is stored in the memory, but here we always see what is stored. So now if I change the content of A by replacing from 1 to the first row with 11, I press enter. So you can see the same computer memory place has changed to a new value and this makes this environment very, very useful for us and easier to use for working on Python. Now let's see the Jupyter. So clicking on the Windows icon, Anaconda 3, then click on Jupyter Notebook. It will show you a console when you look at the background, and then it will open up browser Chrome or Safari, whatever you are using. So Internet Explorer. And here you can create a new Python program or an interpreter environment. It will be like a notebook, and this notebook is stored by the extension of .ivynb, which is IPython notebook. So let me create a blank by clicking on this Python 3, and it will open a new window for us with the similar type of environment as we had, but as we had in Spyder, instead of 3 arrows prompt, we have 8 in prompt. So as before, let me import NumPy plus B again, and here enter will not do anything here. Press shift and enter together to get the this environment is more friendly for documenting. So here also it introduces automatic method and three six all of this should also be also make it like it is not used here. So it is also helping in correcting my mistakes. Now again if I press enter nothing will happen, but if I press shift and enter it will open and go to the next line. Now as I said, and this is a documenting environment, so you can also write helping notes for readers of this document that you are creating in the form of a code which works as well. So for example, next I want to tell the user that how to display a matrix on the screen. So instead of writing code, I will say I am writing heading. So if you want to start writing a heading, you can also start writing it by hash. If it is a subheading, you write two hashes. If it's a subheading, three hashes, four hashes, five hashes, and so on. So for example, I made a bigger heading, display. Don't forget to press space after the hashtag. And then after that, I press enter and I write a subheading and I say by using print command. And then I press enter again. This time I don't want any heading, but I want to write the instruction, which is write print and again. This is type. Now again, if I press enter, I can keep writing it, but if I press shift enter, it will format it beautifully for me in the form of a document. And now I can follow this instruction, or any person I want to follow this instruction. For example, the instruction says write print, and within parentheses write a, and then press shift enter, which is missing here in my statement. But let me write shift enter, so it is displaying the matrix for me just like it was displaying in Spyder as well as in console command prompt environment. So if you want to edit anything, you can always go back and instead of num 11 and press shift enter again. Now if you press shift enter for this again, you will see the results have changed. Also, if you want to edit this, you can double click and go back to the display and then and press shift plus enter. And now you actually press shift enter. So your command is updated. Now again, we can now say b is equal to np dot matrix multiplication mat null a with a transpose of it, and now press shift enter and then let me print b and then shift enter again. So this is the result. So if I again go back and correct the matrix here and then I press shift and then I the final result. So restart and run all the cells. So once that is done, the correction is applied and also the final result. So you don't need to shift enter everywhere again and again. So this is a Jupyter environment which is very useful and handy if you want to document your code. But if you want to write programs only, Spyder is a very good environment. It shows you what is happening inside, and we will be using Spyder in our coming lectures. But if you want to do much inner detailed upgrading of Python, then better use the prompt environment for Anaconda. So this concludes this lecture.